All right, welcome to Chapter 7, Pesticides in the Environment. This one's going to be a relatively decent size. There's about 34 slides that we got to go through. And without further ado, let's dive into pesticides in the environment. All right, so the environment is a concern that is shared by both public and private, right? Public and pesticide applicators alike. Even more so every day, it seems like more and more people are concerned with the environment, concerned with what they're eating, concerned with chemicals. Everyone wants to go organic. And so we need to, be conscious of that. The EPA created classifications of pesticides, and now more products list environmental effects. The EPA requires manufacturers to submit extensive data on environmental tests for pesticide products, as well as reviewing and reevaluating existing registrations, right? So they're always monitoring products that are on the market for us to use. What does the environment consist of? Well, it consists of air, soil, water, plants, animals, houses, restaurants, offices, factories, and everything contained within them. As pesticide applicators, we must consider the effects of pesticides within the environment. The questions that we need to ask ourselves is, where does the pesticide go after the application? What are the effects on non-target sites? How can we minimize harmful effects overall? So we need to always have that on the front of our mind whenever we're doing pesticide applications. So we're going to talk about solubility is the ability of a pesticide to dissolve in a carrier, usually water. Highly soluble pesticides are more likely to move with water, surface runoff, or going through the soil. And then we have adsorption, not to be confused with absorption. This is adsorption, which is the process of binding to soil particles. Oil-soluble pesticides are more likely to bind with clay and organic matter and less likely to move from a site. So let's talk about the word persistence, okay? Persistent pesticides is the ability of a pesticide to remain present and active in its original form for an extended period of time prior to breaking down. And how we generally refer to that as a half-life. So how long does it take the product to go to half strength within the environment? The longer the half-life, the longer the pesticide persists in the environment. And pesticides after application or spill is called, pesticides after application or spill is called residue. Residue can be desirable or undesirable. An example of desirable residue would be if you're doing a mosquito application, you're treating, the surrounding environment, surrounding foliage. You want a residue, so if mosquitoes go to the resting sites, they come in contact with the insecticide and they die. An undesirable residue would be, if you wanted it to be absorbed and it wasn't, and then somebody comes into contact with it. Most important, preventing persistent pesticides from moving off site. And how do they move off site? Well, they can leach, which means they penetrate into the ground. Due to improper handling, they could be going off site, spills and whatnot. If you spill it on the street, where does it go? Does it go down the drain? Where does it go? Drift from the wind carrying products, or runoff. So you spray something, it rains a little bit later, and then it washes away with the rain elsewhere. The rate of pesticide breakdown relates to persistence of the pesticide. So pesticide breakdown can occur rapidly or over years. It really depends on the product. Chemical degradation is the breakdown of chemicals without living organisms, usually with water. And the reason why they say without living organisms is because there is microbial action. And that's where soil microbes and fungi help break down chemicals. It's one of the main ways that chemicals break down. The other way chemicals break down is through photodegradation. Photodegradation is sunlight breaking down chemicals. As far as insecticides go, that photodegradation is probably the number one as far as as far as breaking down chemicals. And now they're trying to create products that are UV resistant, and they have a lot longer life. So you take bifenthrin, it can last, I don't know, 4 weeks in the environment. That's about the interval is 4 weeks if you use the highest rate. And then you take a product like Scion, which is still a synthetic pyrethroid, but that one, it says that it lasts 75 days. So that's a huge difference in how long it can last within the environment. Okay, so let's talk about some pesticide characteristics. Volatility. Volatility is pesticides turning into a gas or vapor. Some products are more volatile than others. Volatilization chances increase with temperature and wind. So when you have higher temperatures and high wind, you're likely to have a volatilization occur. And then also low relative humidity is also when it can occur. So how do pesticides move in the environment? Well, they can move through air, which would be movement away from the application, through wind. Generally, it's called drift. Pesticide applications outdoors can drift very easily off-site. It's not as noticeable indoors, but it can happen. You might have ventilation systems that are moving spray around. And how we can reduce drift is through adjusting our spray droplets, dust, vapor, soil particles. That's all ways that it can move around. And if you're not watching the presentation, if you're listening to this or you're just looking at the notes, I have a picture of a tornado that's going through what looks like farm fields. And surely those farm fields are probably being sprayed with some sort of pesticide. And no doubt the soil that's being thrown around has some residue in it. Pesticides can move in water through runoff or leaching. And runoff is surface movement. So say you do an application on a lawn and you get some overspray on a sidewalk and then it rains. Well, that pesticide is not going to absorb into the concrete. It's going to move with the water. So where does it go? Probably the storm drain and to wherever that's going. Leaching is down into the soil. So the big worry with leaching is it getting to groundwater. And we'll touch base on that a little bit further in this presentation. But runoff and leaching occur when too much pesticide is applied in an application, or too much solutions applied, I should say. If there's a spill with rainwater or irrigation, and with highly soluble or persistent pesticides. Runoff outdoors, you're looking at drainage systems, streams, ponds, surface waters. Runoff can move very vast distances, and that's where it can go. It can go into all these things, right? The drainage system, streams, ponds, any sort of surface water. Leaching, groundwater, that's mainly what we're concerned with, is pesticides getting into our drinking water. We do not want that. Indoor applications, you might have floor drains. You could have water systems. You always want to look into special instructions on the product label about the movement of the pesticides. Something to consider would be setbacks or buffer requirements from wells or standing water. A lot of insecticides have buffer requirements from standing water because they're toxic to aquatic life. How pesticides move in the environment. I put up a picture from the National Corps Manual, and it's basically showing that irrigation is showing evaporation and volatilization. It's showing that leaching down into the ground through leaching and percolation. It's showing wind, runoff, where there's a hill going down to surface water. It's showing all these things, and I highly encourage that you take a look at this picture. It'll explain a lot. How do we prevent drift? Well, the research shows that a large percentage of pesticide never reaches its target due to drift. Drift can cause serious damage, off-target crops. It could harm bees, contaminate soil, animals, human health. It's impossible to eliminate drift. And, that's kind of one of those things where you think about it and it's like, yeah, it's pretty much impossible. Even if it drifts a foot, it's still drifting, right? But we can reduce drift down to acceptable levels. You don't want something to drift into the neighbor's yard, but if it drifts over a foot and it's not going to damage anything, well, then I would suppose that would be acceptable. So how do we reduce the drift? Well, for spray drift, it occurs more frequently with a vapor and dust. Avoiding spray drift, we want to adjust our droplet size, make it as large a droplet as possible. We want to be coherent of the wind direction and wind speed. You really don't want to spray above 10 miles an hour. My technicians in the field, we carry wind meters, and especially when we're doing mosquito applications and we're doing perimeter sprays and things like that, in order to stop drift, we are always checking wind. It's different when you're doing an herbicide application to plants and you're directing it right at the plant. You're doing a very niche applications on these plants. But if you're doing like a perimeter treatment and you're using a mist blower, drift is going to occur. And it's just a matter of how do you reduce it. So we actually reschedule when we get to a certain point in wind. And I leave that to my technician's discretion. I say, hey, look, man, this is on you. You tell me if you can perform the application or not. If not, then we'll reschedule it. It's no big deal. And most of our clients, they understand that, right? Because they understand that we're looking out for them. We're looking out for their neighbors. We're looking out for the environment. Most people are pretty understanding. But larger droplets are less likely to travel greater distances, and higher pressures with small droplets are likely to cause drift. Droplet size. Nozzles are configured to provide a range of droplet sizes. Regardless of the type of nozzle, small droplets can occur and drift. So even if you have it on a very thick setting, you're still going to get small droplets that come off of that. There's various different spray nozzles, and they're classified based on what they are and how they emit liquids. And those were classified by the American Society of Agricultural and Biological Engineers. And they range from extra fine, very fine, fine, moderate, coarse, very coarse, extra coarse, and ultra coarse. And those are all abbreviated, XF, VFF, and so on. But the symbols of those indicate the droplet spectrum. And they're also color-coded, which is nice. Okay, some other factors to think about. Thickness of spray solution. The thicker the solution, the larger the droplet size, the less likely to drift. We could also add some drift control additives, which if you've ever seen that, it's pretty cool. If you haven't seen that, you can actually spray out a distance and just watch all of the droplets just drop straight down to the ground. It's pretty wild to see, actually. But some drift control additives could increase the likelihood of drift. So you have to be careful. And like I said, you have to test these in smaller areas. Be coherent, be conscious. Also be conscious of the wind speed and the direction, which we talked about. But certain labels of products may say here's a maximum and minimum of wind speeds to perform applications. And you have to understand the label and know your products. And then at the same time, you need to know the weather. So if you're out there and it's breezy, but you really don't know what mile per hour it is, well, you just need to pick up a wind meter, and then you'll be able to know. You also want to avoid inversions. Inversions is when the ground level is cooler, and because of that, the air is warmer, and so it pushes pesticides up and laterally along the ground to off-target sites. This is more of a concern with herbicides, I would say, because you could cause a lot of off-target damage. And then also your height above ground that you're spraying. If you want to reduce the drift, spray closer to the ground. Makes sense, right? You're not spraying high enough to where it could drift away into an open void of a space. So how do we reduce drift? Perform spray applications in between 3 and 10 miles per hour. 10 miles an hour is on the very high end. If you've ever seen 10 mile an hour wind and see what spray droplets do, 10 miles an hour is pretty high. But there's some areas in the country where 15 mile an hour wind is consistent all the time, and you kind of have to do it. You want to spray downwind of sensitive areas. You want to use the correct nozzles and pressures. Use drift additives as necessary. Apply closer to the ground and leave an untreated buffer downwind. Okay, so let's talk about temperature inversions. The air at the ground level is cooler than above it. It causes air to move laterally. Inversions, when that happens, it can drift for miles. So it can cause some serious damage. You can identify this through smoke and see how long smoke lingers. If smoke is lingering, then you know that an inversion is likely occurring. It can occur any time of the day and at any height above ground. Most common, it occurs in the early evening hours. It can intensify at night and persist through mid-morning. Can observe inversions with the use of smoke. If smoke hangs around and rises a little, inversions exist. Using 2 thermometers, one at ground level and one elevated, you can also diagnose if there's an inversion. And do not apply pesticides under inversion conditions. Vapor drift. So vapor drift is volatile pesticides transforming into a gas under the right conditions. Usually occurs during hot weather. Can drift farther and for longer time than spray droplets. Only pesticides susceptible to volatilization can have a vapor drift. Choose pesticides with a low volatility in order to stop vapor drift. And many products recommend not making applications above 85 degrees Fahrenheit. I will say that in my practice doing mosquito applications, we do not do applications above 85 degrees. And that's because it vaporizes on the plant material and it can look like you applied an herbicide to plants. So that's why we don't do it. Dust and particle drift. Movement of solid particles. Many particles can remain active attached to soil particles. If blown off site, they can contaminate or damage sensitive areas. Indoor fans, you'd want to turn off the fans, the HVAC equipment, air circulating systems, and that's how you would avoid dust moving around. So what's the applicator's responsibility? You are legally responsible for any damages from off-target movement of pesticides. Let that sink in. You are legally responsible for any damages from off-target movement of pesticides. And so you need to be aware of this. You want to assess the vulnerability of surrounding areas, right? What's around you? Is there a school? Is there a street? Is there a daycare? Where's the neighbor? Is there a fence? What's on the other side of the fence? Is it a pool? Is somebody tanning by the pool? Like, these are all things that you need to be aware of when you're out there in the field, because it can cost you. It can be a very costly mistake to not assess your surroundings. You also need to evaluate the weather. Is it going to rain? When is it going to rain? Is it going to be windy? What's happening out there? What can you expect? What can you do in the field? When do you have to call it a day? Also, adjust your equipment. Make sure that you're doing what you can to reduce drift. And keep people and animals out of treated areas per label instructions. Remember the re-entry interval, REI. You want to know that. And like the base of the REI is when sprays have dried and dusts have settled. But there can be additional REIs. Some products are 48 hours, some products are 6 hours. It really all depends, and you need to take a look at the labels. So let's talk about sources of water contamination. There's 2 different kinds. There's point source pollution and non-point source pollution. And we're going to start with the point source pollution. That's like a spill entering a storm drain, back siphoning into water supplies, contaminated surface water entering sinkholes, repeated spilling at mixing and loading sites, careless handling of wash water at cleanup sites, improper handling, leaks at storage sites, improper disposal of containers, rinsate, excess pesticides. Those are point source pollution. Non-point source pollution is widespread movement of pesticides in streams, groundwater, agricultural fields, right-of-way applications, turf areas. So it's a little bit different. Think non-point is big and point source is relatively small. It can be large, but it's not like you're contaminating a stream or a river or things like that. Okay. So surface water is a major source for drinking water, right? Ponds, lakes, streams, ditches, rivers. And there's a lot of factors that can affect runoff into these areas. For instance, erosion or the slope. How quickly is something going to erode down into a lake or river? How much vegetation cover is on the hillside? What are the soil characteristics? Is it sandy? Is it clay? Is it loamy? What's going on? What's the pesticide characteristics? Is it persistent? Is it very water soluble? What's it going to do? And then also rainfall intensity. If it downpours 3 inches in an hour, well, some stuff's going to move around, right? But there's a potential problem for majority of outdoor pesticide applications. And we need to be conscious of all this stuff. So pesticide contamination of groundwater. Groundwater provides up to 70% of water for public and private water supply. Once it's contaminated, it is difficult to rectify. It's found under bedrock between soil particles, gravel, and rocks. It's a source for wells and springs. Soil, sand, gravel, fractured bedrock that is saturated. That's what's called the saturated zone. The boundary in between the saturated zone and unsaturated zone is called the water table. So let's talk about leaching. Leaching is the number one way that pesticides will get into groundwater, and that's pesticides moving downward through the soil. And the pesticides that leach do not bind well to soil particles. They also resist breaking down. They have a low adsorption rate, and they're highly persistent. So pesticides that adsorbs, binds to soil, will not easily leach. A good recommendation, not a recommendation, but a good example of that would be glyphosate. Glyphosate binds to soil very, very well. It's one of the top products that's recommended to be used in planting beds to treat weeds because it binds to soil. Once it touches soil, it's not moving. Unlike imazapyr moves a lot, and we do not want imazapyr out there in the world. Soil properties and environmental conditions can also affect the leaching potential. Okay, so let's talk about some soil properties because this can affect how pesticides move, how fast they can move. Are they going to get into groundwater? Things like that. Soil properties are broken down into a few different things. We have texture, structure, organic matter, and permeability. The texture of soil is sand, silt, and clay. And water moves faster through sandy soils. Sand is actually a very coarse soil. I know you wouldn't think that when you hold it in your hand, but water runs through it very easily. It's very coarse, and it's the most prone to leaching. The structure of the soil, so the shape and arrangement of soil particles, the pore spaces within the soil. Is it heavily compacted? What are the layers looking like, etc.? And then we have organic matter. Organic matter would be considered like the loam aspect of it. It's decaying plant material. Decaying plant material has a greater ability to hold and absorb pesticides. Permeability, that's how freely it can move towards water. So sand is very permeable. Clay, not as permeable. And then we also want to take into account the depth of the groundwater. Where is the water table? How long would it take for something to penetrate into the groundwater? So how do we prevent surface and groundwater contamination? Well, first of all, never apply directly into water unless you're doing aquatic treatments. That's the only time where you could apply pesticides in water. Pesticides that could contaminate groundwater must have a warning statement. I've seen these on some fungicides that had groundwater precautionary statements. You want to take extra precautions, especially in sandy soils. And then we also have best management practices, which are common sense procedures when applying, mixing, and loading and disposing of those pesticides, of any pesticide. So preventing surface water and groundwater contamination continued. IPM principles: only apply pesticides when necessary. So if you don't need to apply a pesticide, don't. Do a different type of control method. Proper application methods, while also using the least toxic product to achieve the objective. You want to calibrate your equipment and do your best to spot treat. Don't do broadcast applications. Identify vulnerable areas. Well, what are some vulnerable areas? Sandy soils, wells, streams, rivers, ponds. Be conscious of that. Also, do not mix or load near water. Try and stay at least 50 feet away. That can't always happen, but you can do your best to do that. And then also keep pesticides away from wells. That goes for the storage of it, the application, mixing, because those wells are direct entry into the groundwater, and we don't want to contaminate that. Remember, it's really hard to decontaminate groundwater. Also, avoid back siphoning, reverse flow of liquids. So if you put a hose in a water tank and fill it up and the hose actually submerges in the water, back siphoning can occur, which is why there's air gaps between the water supply line and the tank discharge. Terraces and tillage practices. This is more on the agricultural side. Leave plant residues because that can absorb pesticide material. Also, timing of applications. Check the weather. Is the ground saturated? What are the wind conditions? Use products less likely to leach. You want pesticides that can adsorb to the soil, less persistent. And handle pesticides in a safe manner. Contain spills. Check for leaks and damage. Follow all the label directions. So how do we prevent harmful effects to sensitive or non-target organisms? Outdoor sensitive areas would be considered, schools, playgrounds, high traffic trails, endangered species habitat for animals and plants, honeybee sites, wildlife refuges, domestic animals, livestock, ornamental plantings, food crops, feed crops. Indoor sensitive areas would be households, places of work, shops, daycares, hospitals, food storage and preparation areas, domestic animals, and ornamental indoor plants. If sensitive areas must be treated, absolutely use special precautions. So what can happen? Effects on non-target organisms. They can be immediate or long-term consequences. Also, nearly all pesticides can cause phytotoxicity. Phytotoxicity is damage to plants. And that can be caused by high rates, timing, conditions. It can happen to any part of the plant. It's mainly from herbicides and surface runoff or root uptake. So let's talk about bees and beneficial insects. As pesticide applicators, we must be aware of bee activity. Bees can travel as far as 3 miles before applying. They can travel as far as 3 miles. Before applying pesticides toxic to bees, you should notify beekeepers in the area. Now that's all fine and dandy in thought, right? But what if your state doesn't have a beekeeper registry, or some guy just became a beekeeper and he doesn't know that there's a registry? So I would say take that one with a grain of salt, but if you can, absolutely notify the beekeepers in the area. The main concern would be insecticides. Look for the bee hazard icon on the label. It was created because of a large kill caused by a imidacloprid to a flowering linden tree in Oregon. And it was a massacre of bees, and it really caused an upstir. It actually made national news, and that pesticide applicator was fined and jailed. Do not apply to flowers. Obviously, bees are going to go to flowers for pollen, and so we don't want to apply to where they're going to go. Choose the least hazardous insecticide and application method. How do we protect fish, wildlife, and livestock? Well, fish kills generally happen from acute effects and water pollution from insecticides. So you want to leave a buffer zone, right? Bird kills, they can die from ingesting granules, baits, treated seeds, from direct sprays, contaminated water, or consuming prey that was exposed. And like we talked about earlier in this presentation, say a mouse eats some rat bait, runs outside, dies, and a hawk comes get it, that hawk can die. And so that's a way for it to transfer in the food chain. And that would be considered a secondary poisoning, is consumption of dead animal that contains pesticide residues. So we need to protect endangered species. What are endangered species? Well, they're on the brink of extinction, which is not good. Threatened species are likely to become endangered species. You might as well classify them as endangered if they're going to become it. Pesticide products can harm endangered species. Consult county bulletins for special precautions. Look at your endangered species in your area and create buffers, reduce rates and timing to protect those endangered species or threatened species.